Okay, so plugging in is very useful, especially when you have a multiple choice. You have a whole bunch of choices and they ask you which one is the solution. Sometimes even if you don't know how to do the problem, you can just solve it by plugging in each choice. So get good at plugging things in. Okay, so over here we have two equations, and we're asked if the 2, 2 is the solution. So 2, 2 means the first value is x value, second value is y. So this is saying when x is 2, y is 2. So we plug it into the equation and we see if it comes out true. So we have y equals negative 4x plus 6. Thick. Okay, so now we plug in the point. Y is 2, x is 2. Over here it's easy because they're both the same, but be very careful about mixing them up. Okay. Now, negative 4 times 2 is negative 8. Plus 6. Now, if you haven't mastered adding and subtracting with negative numbers yet, check with your calculator. If you're not 100% sure, don't just do it in your head and guess. Check with your calculator. You have the calculator, use it. So negative 8 plus 6 is negative 2. So this shows that 2, 2 is not a solution to this of the system because it doesn't fit even with the first one. So even if it fits with the second one, it's not going to be a solution. So that's that. Here we have a similar problem, right? We can solve this also by plugging in. It's saying that when x is 3, y is 7. So now we can plug that in to our equation and see if it comes out true. Always write out the equation, don't skip steps doing things in your head. Y is 7, careful not to mix them up. X is 3. So let's see, negative 4 times 3 minus 5. 7 equals negative 12 minus 5. Again, if you haven't mastered adding and subtracting with negative numbers, use your calculator. So we have 7 equals negative 12 minus 5 is negative 17. So again, this would seem to fail. We can also solve this, and this is also useful to know, by graphing. And it's super easy when it's y equals like this, and you don't even have to manipulate it all. Let's start with the first one. This here tells us that the y-intercept will be negative 5. So we make a dot there. 1, 2, 3, 4, 5. We have a point here. And they tell us that the slope, this is going to be the slope, is negative 4. So that means for every 1 over to the right, it goes down 4. So 1 over to the right, down 4. 1, 2, 3, 4. So that's going to be right there. And if you should do this with graph paper so it comes out exact. Okay, if I need to make it longer, I'll make it longer. Now let's do the same thing with this equation. We have the y-intercept is negative 2. So we're going to make a dot down there. 1, 2. And this has a slope of 3. So for every 1 to the right, it goes up 3. So 1 to the right, 3 up, 1, 2, 3. That's going to be right there. So now if we continue this line, right, for every, it goes down like that, we can see very clearly, even without drawing it perfectly, that 3, 7, which is all the way over here, 1, 2, 3, 7 up, 1, 2, 3, 4, 5, 6, 7, we can see very clearly that that is not going to be a solution. They intersect here and then they just part ways. Okay, so that's 2 ways of doing that. Okay, another similar problem is the last kind of this that we're going to do. You can solve this also by graphing. and I encourage you to pause the video and try to do it yourself on paper first. So we have the y-intercept of the first is going to be at 3. So 1, 2, 3. And it has a slope of 2. So that means for every 1 to the right, it goes up 2. So 1 to the right, up 2, 1, 2. 1 to the right, up 2, 1, 2. Up to the right. Okay, and we have negative 3x. Well, first let's start with the y-intercept. This also has a y-intercept of 3. Oh, so that shows that they're going to intersect at 3 because they both have the same y-intercept. We don't even need to do anything else. Let's just finish it up though. 1 to the and the slope is going to be negative 3. We see that from here. So this is the y-intercept. 1 to the right, down 3. 1, 2, 3. 1 to the right, down 3, 1, 2, 3. So we can see pretty clearly that the solution is going to be at, it's going to be over here, right, where x is 0 and y is 3. And that would be the solution. Okay. This we can solve by elimination, where you have 2 equations where one has a negative coefficient and the other one has a positive coefficient of the same coefficient. We can add them to eliminate the variable. So let's see, over here we have, and I like to write a plus on both sides because a lot of times people forget to add, or they subtract instead of adding. Okay, so do everything slow and steady. Don't rush. Don't do things in your head. Write everything out. Okay, so now adding them, right, we have this negative 2x and 2x. So when you combine them, they eliminate each other. You got 0x, which is 0. So adding 5y to 9y, we get 24y equals, again, if you haven't mastered this yet, use your calculator. Negative 24 plus 24 is 0. So dividing each side by 24, we get 0 divided by 24 is 0. You can check with your calculator if you don't know that. So we're getting y equals 0. Now we can plug that in back into either equation to solve for x. So let's say we want to use the first equation. Negative x plus 15y equals negative 24. Write out the original equation. Do it step by step. Don't skip. Okay, y equals 0. So that's negative 2x plus 15 times 0. Plugging in a 0 for y, because that's what we found. Equals negative 24. Negative 2x, 15 times 0 is 0, equals negative 24. Divide each side by negative 2. If you're not 100% sure, check with your calculator. This is going to come out to 12. Okay, so I'm getting an answer, x equals 12, y equals 0. We can double check that by plugging it in. So here, let's see, negative 2 times 12 would be negative 24. Y 0, 15 times 0 is 0, equals negative 24. That checks out. What about the other one? X is 12, so 2 times 12 is 24, plus y is 0, so 9 times 0 is 0, equals 24. Checks out. Okay. Again, this is works the same way. You have a negative 5x here and a 5x here. So I'm just going to use theirs. Right, so by combining them, adding them, we get 17y equals negative 7 plus 24 is 17. divide each side by 17. We get y equals 1. Now we can plug that into either equation. This one looks easier because this one's got negatives. I don't like negatives. So I'm going to use this one. You can use either one. 5x plus 4y equals 24. We know that y equals 1. So we get our answer, x is 4, y is 1. So that comes out to the point 4, comma 1. Right, and if you plug that in here, it should work. Negative 5 times 4 is negative 20, plus 13 is negative 7. 4 times 5 is 20, plus 4 times 1 is 24. So, checks out. Okay, I'm not going to do all of these, but they all work the same way. Maybe I'll just do one more. 8x, right? Again, we can eliminate by adding because this one's negative, this one's positive. So 8x plus 8x is 16x. These eliminate each other. Don't forget to add both sides. Again, you should be doing these on your own as well. Okay, now we can plug it into either one. Forget that negative there. Not that it matters here, but just be careful about that. And there we have our answer. And when you're doing this on the test, of course, you should always check back. 2 times 8 is 16. 4 times 2 is 0. That works. 16, 0. Check. Okay. This works the same way. You would add these two, right? Adding both sides. A negative 5 would cancel out the 5y, right? You would get 10x equals 40. I said I wouldn't do another one, but this one looks super easy. So, and I'm probably going to mess it up because I'm doing it too quickly. So I'm getting x equals 4, y equals 10. Check back here. X equals 4. That would make this 32. Y being 10, that would be negative 15. Looks like I probably made a mistake. No, that's right. Y equals 10. Good. This is similar. There's just one small knack here. Notice that there aren't there isn't anything that can cancel out. So all you have to do is notice we have a negative 2x here and 16x here. And all we have to do is multiply this top equation by 8, the whole thing, meaning both sides, everything, multiply it by 8, and it will turn into negative 16x plus 40y equals 4. So then it'll be able to cancel out. I'm not going to do the whole thing here. But I want you to get this concept. You should know that you can make it so that they're eliminatable by multiplying either one or both equations, right? This way we did it by eliminating x. You can also do it to eliminate y. If you wanted to eliminate y, what you would do is multiply, let's say, the top equation by, let's say, -3, and the bottom by 5. This would get you 6x minus 15y equals -39. 5 times 16, 90x plus 15y equals 125. Okay, alternatively, you could have multiplied the top by 3 and the bottom by -5, so that you would have gotten, this would have been plus, and this minus. Alright, the point is you want one of them plus, one of them minus, so that they can cancel out. Okay, this is going to be the last one for systems of equations, linear systems of equations. Same thing here. We can, let's say, multiply this by -4, because we've got a -4 here, and multiply this one by 6, so that way we will get a 24y up on top. And on the bottom, we'll get a -24y. Okay, I'm not going to bother doing that. Alternatively, you can also cancel out the y's by doing the other way around, multiplying the bottom by -6 and the top by +4. Then this would be positive and this negative. Alternatively, you can do it by eliminating the x's. To do that, we could multiply the top by 7 and the bottom, right, in order to make these both 77, multiply the top by 7 and the bottom by -11, right, so that we would get our 77x up here and -77x down here. Alternatively, we could have multiplied the top by -7 and the bottom by +11, so we would have gotten a -77 up here and a +77 down there. So that's it for systems of equations, and we'll do systems of inequalities next.